Alright, on this video we'll discuss about integration by parts, and usually the formula is written as the following. Integral of u dv is uv minus integral of v du. As simple as that. Alright, let's do some examples. Okay, first we want to compute the integral of x cosine x dx. Okay, so our first problem is to determine which one is our u. Okay, and we can always use ILATE to find the u. What is this ILATE? So ILATE. Okay, this ILATE stands for inverse trig. L is for logarithmic, A is for algebraic, T is for trigonometric, and E stands for exponential. So most of the time, the choice of u always follows these ILATE rules. What does it mean? It means that whenever we have some choices, let's say here x is a polynomial which is an algebraic expression, and cosine x is a trigonometric expression. So whenever we have two choices of u, always choose the one that appears first on the ILATE. So on the ILATE, algebraic appears first. So choose that x as our u. Alright, so let's use that. Put u equals x. Using u equals x, then the u is dx. And the rest, which is cosine x dx, is our dv. So this is u and that is dv. So that's dv. Okay, let me put the other way around. dv is cosine x dx. If dv is cosine x dx, then our v is sine x. And why is that? Because the derivative of sine x is cosine. Okay, now we are ready to apply the formula. So integral of x cosine x dx equals to u times v. X times there's another call, don't worry about that. So let's go back to what we left before. So the u is x and the v is sine x. Okay, minus integral of v du. The v is sine x and du is dx. And we have x sine x. What is integral of sine x? Is it cosine x or minus cosine x? That's right, it's minus. So minus minus become plus cosine x, and don't forget to put the constant. We are done. Alright, let's look at the second example. So now here we have integral of z cubed merge log of z. Let's see, this expression is polynomial which is algebraic, and that expression is logarithmic. Remember, we need to use highlight. Logarithmic comes first before algebraic, so choose u equals natural log of z. Then we have the u equals 1 over z dz, and here the rest, which is, so we selected natural log z as our u, and the rest will become our dv. dv is z cubed dz. So what is our v? Well, we can obtain v by simply integrating z cubed. So what is the integral of z cubed? Add 1 to the power and then divide it by whatever appear on the power. Okay, now we are ready to use the formula. So uv minus integral of v du. U is natural log of z, v is z to the 4th divided by 4 minus integral of z to the 4th over 4 times du, which is 1 over z dz. So then we have, let's rearrange a little bit over here, 1/4 z to the 4th natural log of z minus, pull out the 1/4, and then we can simplify z to the 4th divided by z as z cubed. So then we have 1/4 z to the 4th natural log of z minus 1 over 16 z to the 4th, and don't forget plus a constant. Okay, let's do the next example. So here we have integral of arcsine x dx. Well, in this integral we don't have many choices for you. That's the only function that we have, so then it is natural to choose our u to be arcsine x and our dv to be dx. From this choice we have du equals, well, unfortunately you need to memorize or know how to derive the derivative of the inverse trigonometric function. So du is 1 over square root 1 minus x squared dx. And from dv equals dx we have v equals x. Alright, so this guy is u and that's our dv. According to the formula we have uv minus integral of v du. Okay, so u times v, that's our u, that's our v. So let me write the v verse. So x times arcsine x minus integral of v du, x times 1 over square root 1 minus x squared dx. Alright, so in order to be able to solve this problem completely, we need to be able to compute this integral. What is the best method to compute that integral? Can we use some substitution? Let's try. So what happens if we substitute, let's use a new variable, z equals 1 minus x squared. Then the z is minus 2x dx. Okay. Notice that on the integral we have x dx. Okay. Solving for x dx, we have, so that's our x dx, minus half of dz. It means we can delete that x dx and then put in minus half dz on that integral. Okay, so let's do it. X arc sine x minus integral, that's x dx is our minus half dz. Okay, and we also have 1 over that square root, 1 over square root of z. Okay, let's rearrange how we write this expression. First, put that negative 1/2 to the front, so it becomes plus 1/2. Alright, so take that away and then put it here. Okay, and then we can move this guy and put it, oops, hold on. Alright, so let's switch, write this guy first and then the z. 1 over square root of z dz. Now how to integrate this? Notice that we can make this into a power function. This is simply z to the power of negative 1/2. So z to the negative 1/2 dz. Then we can easily integrate that to get x arc sine x plus, so raise the power by 1, increase the power by 1, and then we have, what do we have here? That's all we have, right? Because we have 1/2 multiplied by 2, which is 1. Check it again to make it sure, if you want to make sure about that. Alright, and at the end we need to rewrite everything in terms of x, so we need to put back the z equals 1 minus x squared here, equals x arc sine x plus square root of 1 minus x squared plus constant. Okay, we will see a more complex integration by parts on the next video. Thank you for watching. Bye.